everyone, my name is Rachel. I'm with the NPCR lab, and in this tutorial I'm going to show you guys how to use the ML-Agents API from Unity 3D in order to import your own custom Unity environments and use your own custom learning algorithms. So what that means is you can take any Unity environment that you've already made to work with the ML-Agents package and import it to the mlagents-envs part of the API in order to use your own custom learning algorithms. It's just going to be a basic tutorial. We're not going to go over how to make your own custom learning algorithms and stuff like that, but this should give you an idea of how to get started in working in this kind of environment so you're ready to go. Alright, so let's get started. The first thing you want to do is go ahead and open whatever project from your Unity hub you want to use. I'm going to use the rollerball environment that I made in a previous tutorial. If you want to watch that, the link should appear now. Okay, so just to be clear, you can use any environment, but it has to already be set up with the ML-Agents package. So what I mean is that I already have this working. So I have my sphere agent ball, and it's going to run into this target cube. And if I look over at my agent over here, I've already created the agent script, which if we just take a quick peek at that, is using the Unity ML-Agents package and has all of the code it needs to be able to train properly. Okay, the other thing that's important here is that we've created the decision requester, how often do we need to request actions to take, and the behavior parameters. So we've specified a behavior name. In mine it's called rollerball, and whatever yours, it might be called something different. And just remember that behavior name for later. And we've set up all these other things. Very important here that you have the behavior type set to default, not heuristic only, not inference. Set this to default if you're trying to train the learning algorithm, which is what we're going to do today. Okay. So one more thing before we build this file is you're going to want to go up here to Window, go to Package Manager, and make sure that your ML-Agents version that you have loaded into your Unity environment project is the correct version. So what I mean by correct version is that I personally just installed the ML-Agents API earlier today. So the most current ML-Agents version that I'm going to use is going to be the published date October 14th because there's not a release after that. So if you're unsure of which package you should be using, you're going to want to go into the GitHub for the Unity Technologies ML-Agents, and you're going to want to figure out what published date you should be using based on when you installed ML-Agents on your computer. Okay, so mine's up to date. If it's not up to date, make sure that you select the right version and then click up to date. Now we're ready to build a binary file that we can execute when we're in our Python instance. So go up here to File, go down to Build Settings. Once you're in Build Settings, you're going to want to click on Player Settings. And this is my suggestion to you. Make sure that your full screen mode is set to windowed. Otherwise, it's just going to open this giant screen and it's going to be very annoying to work around. So set to windowed and then change this these numbers based on, however big your monitor is or whatever. And make sure that you have run in background clicked. That's important. Okay, so run in background has a check, and these player settings get saved automatically. So we can just exit out of that. And we're back in our build settings. And we want to make sure that our target platform and our architecture is for whatever operating system that you're trying to interact when you're going to be using the Python API environment with ML-Agents. So I'm going to be working on Ubuntu and my 8664 architecture, so that's all good. And very important, very super important. I cannot stress this enough. It took me 2 weeks to figure this out. You'd never believe it. Okay, so development build needs to have a check. I believe if you're in Unity version for 2020, that's going to be called debugging mode or something like that. Make sure that's checked. I'm using Unity 2019 version, so it's called development build. Make sure that's checked, and we can go ahead and hit build. Just build. It's going to ask, where do you want to save this? So a note on where to save this. You don't need to save it in the cloned GitHub repository, and you don't need to save it wherever you actually built the Unity environment. You can save it in any project location. So I'm going to save it in this arbitrary project path that I've already described. I'm going to give it a name called rollerball build. I did this earlier to make sure it would work, so you can already see that it's there. So when I do that, it's going to automatically save, and it's going to look like nothing's happening. Don't freak out, it's totally normal. In a couple seconds here, something's going to pop up to let us know that it's building the binary file. And there it goes. So we're building a binary file that we're going to execute in our Python environment to connect to this Unity environment that we've already built in order to use our own learning algorithms with it. Alright, so once that's done, it should open your file manager, and we can see that two things just appeared. We have this rollerball build binary file that I've been talking about, and we have another folder with the same name underscore data. Keep these two things together. You need both of them. If you accidentally get rid of this data folder, you're going to be in trouble. Alright, so we're done with the Unity editor. We can exit out of this guy. I'm going to save changes. And now we can get into our terminal. So you want to go to the file path of wherever you just saved that binary file. So for me, in my computer, it's going to be in here. And you can see I have the rollerball binary file here, and I have the rollerball build data here. That's going to be whatever you named it, right? And if you're using Conda, you want to go ahead and activate your Conda here if you haven't already. If you're not using Conda, then you just want to make sure that you already have ML-Agents installed. Same with Conda. Make sure that you already have the ML-Agents package installed. If you don't, you can check out this other tutorial that I made. That should be dropping in the link now. Alright, so now that we're ready to go, we can just load up our Python environment. So however you code is fine. For this tutorial, I'm going to go ahead and show you guys line by line what's going on so you can get a feel for each command and what you need to use in your own code. Alright, so let's make that a little bit bigger so you guys can actually see what's going on. And I have a script that I wrote earlier so you guys can follow along. So the first thing we want to do is we want to import ML-Agents. That's the package we're using, right? So of course we want to import it. And then to make our lives easier, we're going to say from ML-Agents, and we're using the envs part of this API. That's the part that allows us to do our own custom learning algorithms. If you just want to use the PPO or the SAC, you can use the ML-Agents learn part of the ML-Agents API. But we want to use our own custom algorithms. So we're going to say from mlagents-envs .environment. We're going to import this function called Unity environment. And I'm just going to say call it UE because it's kind of a mouthful to type. So now what we want to do is we want to go ahead and load up the environment that we built from the binary file. So to do that, we're going to use the function that we just imported, Unity environment, and we're going to say the file name is whatever you name the binary file. So for me, that's going to be rollerball. You don't need to put the file extension here. But you do need to specify some other things later on. So you can use seed, you can set a seed, and you can also set the side channels. That's not important for us right now, but if you're curious, you can look those up on the official GitHub documents for the mlagents-envs part of the package and figure out what those means. So as soon as you load that, it's going to open up the rollerball tutorial or whatever environment that you had. Do not hit force close, hit wait. That's going to allow this environment to run in the background. So we can go back to our terminal, and now it's very important. What you want to do is you want to reset the environment. So in order to do that, we're going to say env.reset, and that's just going to clear the environment for us and get us ready. And so if you got to this point, then you're doing really good, and it probably means that it's going to work. If you didn't get to this point, you need to go back and check if you built the file correctly, if you have the right versions installed in the Unity environment and on your desktop, and also make sure that you're in the right path and you're working with the correct ML-Agents API. Alright, so now what we want to do is we want to start interacting with that environment. Right? So in order to do that, we're going to have to call some commands that allow us to use and interact with the custom environment so we can feed this to our learning algorithm that we'll define at another point in order to move around and interact with the environment that we specified. So let's just go ahead and check what the behavior specs are. So if you say m.behavior specs, you can get the name of the behavior. And earlier we said that name for this example is going to be rollerball. In your environment, whatever behavior you set in the agent script will be different. So we can just set this behavior name to be a variable so we can call upon it later. And if we check that, it's rollerball, and that's correct. Don't worry about the team equals 0 part right now. It's just not important. But you do want to make sure that that behavior name corresponds to whatever behavior you're working with. So we also want to set this variable called spec, which we're gonna index the environment behavior specs with the behavior name. And if we check that out, it's going to be whatever observation we're getting. So we have an observation shape of 8. Based on the velocity and the position of the agent and the position of the target. So we have one observation, it includes all those things. And we can go ahead and check if this action that we need our agent to take is going to be continuous or discrete. So in my environment, I chose continuous actions that the agent can take. It can roll around in incremental versions. If in your environment you're using discrete, you can also say spec.isAction discrete, and if it's discrete, it'll say the action is discrete. So that's how you can check what you're working with based on your own environment and your agent. So one thing to note here is that we're indexing things by behavior name. So if you have more than one behavior, obviously it's going to get more convoluted. And if you have multiple agents, it's going to get more convoluted. But we're just trying to show you here how to do each part one by one in order to figure out how to put all these pieces together in your own learning algorithm scripts. Okay, so in order to get started, we can call m.reset again just to clear the environment state, and you'll see that in our window that we have open that's actually running the environment, now you can see the agent, which is the sphere, and the target, which is the cube. Alright, so the next thing we want to do is we want to get the environment steps. That's going to give us two things, the decision steps and the terminal steps. We can just call that with this command, and again, we're indexing with this behavior name, right? So if you have more behaviors, you're going to have to do this multiple times. But for us right now, we're just using the rollerball behavior that we set up before. Okay, so if we print that out, we can see right away that it's wrapped in a class. So we want to print the list of the decision steps just to see what that is. And once you do that, you'll see that it has a 0 in there. And that 0 is actually the agent index. So we only have one agent, which is why agent 0 is requesting a decision. And likewise, if we check the terminal steps, there should be nothing in there because we just started the environment. We haven't even run it yet. It's just loaded up, and right now when it's loaded up, the sphere agent is expecting a decision. It's waiting to be told what action it needs to take in order to advance the environment. So we haven't moved anything in the environment yet. We're just trying to figure out what our agent is, which is agent 0, and our behavior name, which is rollerball. And we've set those variables. So now we're going to set a couple more variables called tracked agent. This will help you if you have multiple agents going on. So we're going to say tracked agent. We're not tracking it yet. We set that with -1. And we're not done, which means the agent hasn't finished anything yet. We want to keep going while we're iterating through the episode. And so the next thing we're going to do is set the episode rewards to 0. So since we just loaded up the environment, it's not going yet. It hasn't started going through the steps of the episode. So the episode reward should be set to 0. It should not be getting any rewards. Even if you have a reward for existing, say a negative reward or something, we haven't actually started anything yet. So we're just going to set that to 0. And now we're going to say, okay, our tracked agent is going to be whatever agent is requesting a decision, because that's what we need to apply an action to. So now we have this variable tracked agent. It's going to be indexed from the decision steps, the agent ID 0. That's what we talked about earlier, a couple steps ago. Okay, so now that we have the tracked agent, we can specify the agent action. And this is where you would put in your own learning algorithm. This is where you would hook up your deep learning or your random walk or whatever learning algorithm you want to use. You would specify what action the agent needs to take in this step. So what you're going to do here is, for this example, we're just going to say take a random action. So I'm not going to show you how to actually make your own learning algorithm in this tutorial. You can figure that out on your own, or in future tutorials, hopefully we'll have some stuff like that. So for right now, we're just going to create a random action, and we're going to say that's the action that the agent is going to take. So if we do that, we can go ahead and print that out, and we see that our action is an array. It's just a tensor that has two values. So in my example, my action can apply a force for velocity, and it can do that in a continuous way. So that's why we see floats, because it's continuous, and also we have two things, so it can control the velocity. So that's good. We just created a random action. And in order to actually apply that action, we haven't actually said, hey, sphere agent, take that action. We've just said this is the action that's going to happen. What we need to do next is actually set that action to the environment. So once you do that, now we've just said, hey, agent, in the environment, we're setting your action for this particular behavior based on the behavior name. This is the action you're going to take. Still, nothing has happened in the environment yet. The ball is still in the same place. The cube hasn't moved. The environment has not made any steps yet. In order to make a step, we need to move over here to the env.step command. And once we put that in our Python instance, it's actually going to apply that step to the sphere agent. And you can't really see because it's a really small step and it hasn't done anything yet. So this will make more sense in a couple minutes. All right, so now that we've applied the step and the environment has moved forward, we need to call the decision steps and the terminal steps again to see what agents are needing what. Are they needing actions, or have they reached a terminal state? So we're just going to call the same function we called earlier based on the behavior name. That's very important to remember, that we're indexing based on this behavior name. So if we print those things out, what we should expect to see is that our agent 0, is still requesting a decision because it hasn't reached a terminal state yet. Remember, a terminal state for my example in this rollerball tutorial is if it runs into the cube or if it falls off the plane. So we shouldn't expect it to be in a terminal state. It's still requesting action because it hasn't reached a terminal state. So now that the agent has done something, it's taken some action, it needs to get a reward for that. So we're just going to say the episode rewards, which was 0, update yourself to include a new reward. And the reward is going to be based on whatever you described in the agent script in the Unity editor when the environment was actually built. So we're not saying get a reward right now. We're saying if a reward is supposed to be given at this step in the episode, apply that reward. So if we print episode rewards, we expect to see 0 because in this rollerball example, the agent only gets a reward if it runs into the target cube. It doesn't get any negative reward for existing or a reward for falling off the plane or anything like that. It only gets a reward when it runs into the cube. So it's a sparse reward. So we would expect for this to say 0 right now. In your example, you may have a different reward scheme set up, and you may see that after you take one step, this episode reward has changed. All right, so that's basically the meat of what you need to do in order to run your own custom learning environments. So if we put this in a loop so it'll run multiple episodes with this extra code that I'm going to link in the description for you guys, so don't worry, we can see that it's actually going to take random actions for each episode and run through until it reaches a terminal state, applying rewards. So it's printing out the reward for us just so we can kind of see what's going on. And it's not very good, right? So it's a random walk. It's just choosing random actions. So we don't expect it to be super great or to learn very quickly. So you know, we're expecting it not to do great. But if we go ahead and do this again, we can actually watch in the file that we have pulled up here, in the window that we have pulled up here, our agent moving around, taking random actions during each episode. And that time it just happened to run into the cube, so it got a reward, right? So you can see the reward over here is changed to 1. So for your example, this may be different, but you should expect to see as you're stepping through, as you're calling env.step in your Unity environment that's running in the background, you should expect that to move around. So when you're done with the environment, you want to make sure to close it using env.close. That'll close the whole thing. Only do this when you're done. All right, so I just wanted to add in one more thing for you guys, because you're probably wondering, okay, I know where I'm supposed to put in the learning algorithm to get the decisions, but what am I actually supposed to feed into to whatever learning algorithm I create to decide what actions I should take, right? So if you're using, let's say, deep Q or something, you have to have an input. So your input should be this decisions_steps.obs. That's whatever observations the agent is taking. So that's the observation state, right, from the environment. And since I already closed the environment, the array is empty, but for whatever you have, that array should be full of the observation state vector. So that's really important to know. So that's all you need, guys. That's all the code you need in order to start setting up your own learning algorithms with your custom environments. And just remember that where you actually want to plug in your learning algorithm is when you feed in the observations and get the action. So just brief overview real quick. We built an executable file from our Unity environment. We did that making sure that we had the debugging mode set and check in the binary file. Then we loaded this binary file into our Python 3 environment with our ML-Agents API already set up. And we learned some common commands to navigate the scene. We learned how to get the observation, how to read things about what actions that we've already set up for the agent, and how to plug that into a learning environment in order to take actions. And in our case, we didn't use a learning algorithm. We just used a random walk to randomly generate what the agent should do to keep it simple. And so we did figure out where we should plug in our AI algorithms later, and we got our results, right? We were able to step through the environment and figure out the new environment state that would get fed into the next part of your learning environment in order to figure out what next action you should take. And if you were actually using a learning algorithm, it would learn to take better steps and create better actions as you go along if you set up your environment correctly. So that's it, guys. Thanks for watching. I appreciate you guys paying attention and sticking up with this stuff. If you're curious about our lab, I'm going to put the link in the description below, and all the code's going to be in there. And that's it. And if you want to keep up with me easily, just like and subscribe.